In this section, we'll be discussing inverse matrices. Now, these will be important as we continue on to the next section where we're going to solve systems of equations with matrices. So, let's start with how to find an inverse. So, fortunately, we have our calculator right here, and it is going to help us with this. So, if I go to, say, second matrix is right above the x to the negative 1 button. So, go to second matrix. And we're going to go over to the edit menu so I can edit what A, B, and C are. So under A, I'm going to push enter. And it's asking me the dimensions of matrix A. If I take a look at A over here, on the left-hand side, I have 2 rows and 2 columns, actually for A, B, and C. So I'm going to make A, B, and C all 2 by 2s. So I'm just going to push 2, enter, 2, enter. Next, I just want to, row by row, and insert the entries of each of the matrices. So I have 3, enter, negative 1, enter, negative 2, enter, 2. Make sure you still push enter after the last one. You can see right now up in the matrix I only have a 0, but it's not until I push enter that the 2 actually goes up into the matrix. I'm going to do second quit, right? Second mode is going to quit out of there. I don't want to push clear because if I push clear right here, it's going to get rid of that too. Right? Clear works on ending some programs, but not all of them. So second quit, I know I'm not going to ruin my matrix. So then do the same thing again. Go to second matrix, and now you can see I have the matrix A in there. Okay? If I want to use A again, then I'm just going to overwrite it. I'm going to go over to edit, and I want to edit matrix B. So either go down to 2 and push enter, or just push number 2. And again, it's a 2 by 2. And insert the entries row by 1. So 4, negative 1, negative 6, 3. Second quit. Second matrix, and edit C. I do want to show you that it's going to do different things depending on the matrix, so trust me, there's a reason that I'm giving you 3 examples. Okay, so remember the matrix menu, right? That yellow menu is right above that x to the negative 1 button. That x to the negative 1 is the inverse button. So I'm going to click on that without pushing second in order to get that little negative 1, which means the inverse. Okay? Hopefully you remember that from Module 1. F inverse was f to the negative 1. Well, same thing here. So I'm going to do A inverse, so I need to grab matrix A. So I'm going to go second matrix. And names is where I'm going to grab the matrix and have it show up on the home screen. Edit is where I'm changing the matrix. So I'm done with that. I want to do under names, push enter on A, and then push negative 1 without the second, and push enter. Now, I know what those are as fractions, but let's say that we didn't. Let's say they were harder. Then just go to math, fraction, enter. And it turns them into fractions for me. So inverse matrices are always matrices, right? Determinants were numbers, but inverses are whole matrices. So I want a 2 by 2 matrix. So I have 1/2. And 1/4. And 1/2, and 3/4. I'll put brackets around the whole thing. Because that's what we do with matrices, just to hold them all together. Okay, next one. I'm going to grab matrix B, inverse. Oftentimes these are decimals, and this one for sure decimals. Okay, so that's fine. Math, fraction, enter. And there we are. So in a minute I will tell you the formula that the calculator is using, but you don't really need to know it. You just need to know how to find it on your calculator. Of course, ask your instructor if they want you to show your work. But if you don't need to show your work on how you got the inverse, then you can just refer to the calculator. Oops. Okay, on to the third and last one. So C inverse and that's just whole numbers. So this actually did not give me an example that I wanted, unfortunately. Because every once in a while it's not going to work. Okay. So let's do some more down here. Okay. Every once in a while it's not going to work. It says, even in the directions there, it says find the inverse if it exists. Well, obviously all three of these existed because in my calculator I said find A inverse and it gave it to me, and B inverse and it gave it to me, and C inverse and it gave it to me. If it didn't work, then it would give you an error message. And I'll show you what that will look like down here. Okay. But first, for those of you that hate that the calculator is just giving you the answer, you want to just know where the heck this is coming from, here is your formula. So it says, if done by hand, then we can find the formula, we can use this following formula to find the inverse of a 2 by 2 matrix. Yes, you can find an inverse of higher degree matrices, so like 3 by 3, a 4 by 4, they always have to be square matrices in order to have inverses. But this is the formula if it is just a 2 by 2. So let's say you start off with matrix A that says A, B, C, D. Then the inverse of A is, first they flip-flop the A and the D, right? So the ones that are on that main diagonal there. And then they negated or took the opposite signs of the other two, the C and the B. And then they also divided by the determinant. Remember, those absolute value lines with matrices do not mean absolute value, they mean the determinant. So that's why some of these are fractions and some were whole numbers. Because here, I imagine the determinant was 4, right? So it flip-flopped these two. Right, so it would have made it, the 3 went down here, and the 2 went up here, but then we divided everything by 4, well 2 over 4 is 1/2, right? So it's already simplified for you. And then the -1 and the -2, we take the opposite sign, so that's a +1 and a +2, but keep them where they are, and then still we're just dividing by 4, so 1 over 4 is still 1/4, 2 over 4 is 1/2. Okay, so you can see why some of them are easier to simplify than others, right? So over here, the determinant was probably 6, okay? So some of these simplified and some just stayed as the denominator 6. All right. Next, it says, if the determinant is not 0, then A has an inverse. So my examples above, A, B, and C, all had inverses. So we call A, B, and C invertible matrices, or non-singular matrices. You probably want to just call it invertible, right? But if the determinant is 0, then remember back to this formula, I'm dividing by 0, and that is a huge no-no, right? So A does not have an inverse because I cannot divide by 0. And that means that A is called singular, right? It does not have an inverse. It doesn't have a partner to go along with it. It's just all by itself. It's single. And that is exactly the error message that you will get on your calculator if you put in a matrix that is singular, and a matrix in which the determinant is 0. So let me show you what that looks like. Alright, so it says, which of the following are invertible? So you can do this in a couple different ways. You can figure out what the determinant is, and if it's 0, then say, no, it does not have an inverse. And if it's not 0, then say yes, it does have an inverse. It doesn't even say to find what that inverse is. Or you could, if you totally forget that rule, just plug this in as A and then find the inverse like we were doing on the calculator before. And if it gives you an inverse, well then it's invertible because it has an inverse. We found it, right? You're kind of doing too much for the question. And if it doesn't, if it gives you an error, it says error singular, then you know that it does not have an inverse, meaning it is not invertible. So this one really jumps out to me, right? The determinant here would be 5 minus 5 is 0. So this one is not going to work. So we've already done ones that do work in the calculator. So let's put one in that does not work. I'm going to just put it in as matrix A. It doesn't matter what you're calling it. Just remember what it is. So 1155. Quit. And it was matrix A, so let me grab matrix A. Inverse. And it says no, error, singular matrix. You plugged it in correctly, but it does not have an inverse because that original matrix was singular, right? Remember back to our crazy definitions. It is singular, it does not have an inverse. And if you wanted to check and see, well, what is the determinant of this thing? It better be 0. Let's quit first. The determinant of matrix A is 0. So again, if you forget the rule, well then just check it on your calculator. Okay, so this one is no. Let's do these ones real quick. So this would be 5 times -1 is -5 minus -5. Let me write this out. Determine, we'll call this A, is -5 minus -5, okay, which is -5 plus 5, which is 0. So this is also a no. Here, I have determinant, I'll call this B, just to have them with different names. 5 times 4 is 20, minus 3 times -1 is -3. That's positive 23. I don't care what it is, it's not 0, so therefore the answer is yes. Okay. If the determinant is not 0, then it does have an inverse. And then finally, we already found this one. Determinant of C is 5 minus 5, which is 0, so no. So however you want to do it with finding the determinant and then determining from there, what does that mean as far as an inverse or not, or if you want to just plug in the calculator and say find the inverse and see if it works. Either way, you will get to the right answer. One more thing. We can find the inverse of a larger matrix, right? So for a 3 by 3, a 4 by 4, a 5 by 5, you will not have to do that by hand. We'll for sure only use the calculator, okay? The directions are exactly the same, okay? You're going to input your matrix into second matrix and then edit. I like to just keep reusing A. So here's my matrix. They called it E, I'm going to call it A. So matrix A is a 5 by, oh no, it's a 4 by 4. Just kidding. More ambitious than I need it to be. So it's a 4 by 4. And then just go across each row. 1, enter, 0, 0, 1, 0, 2, 1, 2, 2, 1, 0, 1, 2, 0, 1, 4. If this was a test, I would just double check that your matrix is entered in there correctly, because otherwise there's no way that you're going to get the correct answer. So I'm going to clear this out. Just under names, I'm just going to push enter on A. Nothing else. I just want to match these up and make sure that I did it correctly, because if you miss one number or one sign, then obviously the inverse is going to be wrong, or the determinant is wrong, or the multiplication, or the operation, whatever it is you're doing. So I think it's a lot easier to check it when you click on names. than just checking it under that edit screen. So it does look good. So now I can go ahead and find the inverse. So second matrix, then choose A, or whichever one you want, inverse. And of course I have fractions, right, with that whole dividing by the determinant, it usually makes fractions. Push enter, and there we go. So E inverse equals, and I'm just going to copy that whole thing over. Hopefully this is much easier for you to do. You're not in Word. So let's see, we've got -2, -1/2, 1. And I can't quite see all of it, but it says ... over here. So I can just continue off to the right and I can see the whole thing. My second line. 1. So for sure, if you get a question that has a large matrix like this, and then the question is, whether or not it is invertible, right? Just go directly to the calculator, and then either find the determinant or find that inverse. So that you'll know, right? Determinant is 0, no inverse. Determinant is anything else, then it does have an inverse. Whew, we got it. So there we go.